Good morning, everybody. How are you? Good. Thank you for the intro, Aaron. Deb, thank you as well for helping put it together. I think it's very exciting seeing the turnout here, the people online, but then also we've got an afternoon session as well. I see a lot of very cool 3D printed models. I travel with a bunch. How many of you are very aware of 3D printing? Anybody raise their hand above their ear? Okay, so most of you. I work for a company called Stratasys. Anybody hear of Stratasys? Okay, good. I'm glad he has. He's a user. What did you come here to learn? What do you want to learn from me? Anything?
How much and how fast?
How much, how fast?
How much and how fast?
That is all dependent on what you're looking to print and what your needs are when it comes to print. We can actually absolutely have that discussion. I'll pass around tomorrow. Yeah. Anything else? Much, how fast? Okay. I think we can hammer this down and get you information. So Stratasys is a 32-year-old company. Actually started in a kitchen, but they got kicked out into the garage. Scott Crump, this is actually he's the founder of Stratasys. He and his wife started this company. He was building a toy frog for his daughter with a glue gun on a frying pan. That's how 3D printing got started. So if you think of the majority of 3D printers out there, good morning, how are you? Good. They're extruding a plastic, heating up some sort of filament, extruding it layer by layer, building it up. Speed-wise, it's not the fastest thing anymore. It's faster than CNC in most cases. It's less manual, but it's not the fastest way to do it. But it's the most, I guess it's the technology that you can use real thermoplastics to do. So if you want a polycarbonate, you can 3D print a polycarbonate, or in the whole time we're ABS. The little picture of the first 3D printer, a rendering. This is what most low-cost 3D printers look like today. Okay, this is 1985. That's wrong. First operating 3D printer in 1991. Stratasys is the group that coined it 3D printing. Before that, it was stereolithography, rapid fabrication, rapid prototyping. We called it a 3D printer. We had a marketing guru, John Cobb, if you remember. He coined it 3D printing because he wanted people to not be afraid of it. He wanted people to think of it as this could be in somebody's office, and we could actually produce these prototypes, these parts. If you've ever used a 3D printer, I think it's easier than using my inkjet printer at home. I struggle with my inkjet printer. I just had to change ink, and it took me like 35, 40 minutes to actually get something to print. It was quite frustrating, but nonetheless, so 3D printing. These are pictures of stuff that you'll probably, hopefully see in a museum someday. These are our first printed parts. These are very, very important parts to me. I've been with our company for 14 years now. I have 2 young daughters, and 3D printing is going to pay for their weddings. So I have to keep a job for another 20 or so years. Unless we win the lottery. But that's why I love these parts, the first parts. Think about this. You could do this now with a $300 printer. But back in the day, this was monumental. The fact that you could send something to a machine and it would do this without you engaging in it, without you doing the numerical control. So these are big parts that we kind of feast off. Fast forward to today. This is a mask actually 3D printed on our PolyJet technology, and our PolyJet technology can use 6 different materials at a time plus a support. We just upped that to now 7 materials at a time. They call this a death mask. This was a story, it was on 2020 multiple times to get updates, but it was one person that attempted to commit suicide, tried to remove their head, didn't do it properly, had a new lease on life, but his face was missing. So he basically lived covered up for 1.5 years, 2 years. There's another gentleman that was in a coma, brain dead, but his mother was willing to, she heard this story and was willing to share the facial components and body parts necessary to let this other person have a better life. But her big hang up was to have an open casket. So they worked with NYU Langone Center, and Dr. Rodriguez is the premier surgeon on facial implants. It's not the happiest of stories, so there's some sad, but there's also some happy. But they actually 3D printed this mask to use not only during the open casket, but then also during surgery, because it was very unnerving for a lot of the people that went in to do their work to see somebody that was missing a face and to operate on. So kind of a double whammy, but it was so lifelike that they were able to really power through. And there's much talk of more usage of their 3D printer at the lab for these face reconstructions. You see here, this is the printer printing it. There's the face, and what they do is they do a 3D scan of that person, and then it's usually within 36 hours they're going to have this surgery. So it's a bang procedure to get things done, so they need things to work. So, but if you want to know more, hear more about it, see the 2020, see the original, see the update. The gentleman that actually got the face transplant is actually doing very well. He's smiling. He's learning to talk again. It's kind of like I said, some good came out of a rough story. I don't think this will work as a video. Well, maybe it will. So this here is another piece. Think of it, this is this tiny little piece. You talk about speed and cost. The speed to print that is maybe 15, 20 minutes. Okay? The cost of that is maybe $4 or $5. Well, what it is right there is, we'll see if I can actually play the video because it ties to YouTube, but it's a surgical trainer. It's created at University of Central Florida by a gentleman named Jack Stubbs. He's at the Institute for Surgical Training. So his vision is his mission is to print parts to help people practice to get better at whatever they're doing. One of the things he said to me once, and it resonated, and it still resonates today, was a lot of the mannequins out there or the surgical trainers out there do not simulate what it actually feels to be operating, intubating, whatever, on a 23-year-old male. The cadavers they work with, once your heart stops beating, everything changes. And a lot of not many of the cadavers are young. Most cadavers are old. So they're building up this simulation training library. He said, when you perform or practice on one of these things that does not feel lifelike and real, you actually get worse at it. You actually injure someone, an actual human, versus a surgical trainer. So they're trying to perfect this. This here is for them to do some dissection planes, get some exposure and ligation of these vessels. Let's see if it pops up. may have screwed everything up, but here we go. He sent this to me and he called it a bloody mess. Very nice. But you see him cutting there, obviously in the operating room, at least not where I live. They don't use X-Acto knives, but he's digging in. Like I said, this is a 3D printed part. They printed it where if it went wrong, you'd see a little blood start gushing. But they're digging around in there. And this is something that they're practicing on. These guys are working with Da Vinci robot training. So they're near Nicholas Hospital in Florida, where they do a ton of the robotic training for surgeries. So this is one of those pieces that they're presenting to them to do some practicing. You see him digging around in there. Get his scalpel back out. And you can see him, see the blood on the right side, and then he's digging to get that vessel. But a cool little trainer that takes very little time to build and costs very little money, but allows people to do a lot of dissection. And you'll see the moment where the vessel pops out. I've seen this so many times, I'm still so drawn to it. So, sorry. But you see the layers that they can build into this. And this is all because they designed it this way. The power of this is the design. So the printer's good at what it does, but you can see there he cut the vessel. So we've got some blood going on. Other areas where 3D printing or additive manufacturing is making strides. Well, we could talk about medical all day, but we have some great speakers that'll dive deeper. So I'll look in some other areas. They're getting planes back up in the air. At University of Dayton Research Institute, they're working hand in hand with the Air Force in building custom parts that they're putting on these planes that are grounded. They're grounded because they don't have these components and things aren't working and it's not safe to fly or it's not safe to be in these certain areas. We have a aerospace grade material that can be printed, put on these planes, and they're getting these planes up in the air rather than, what did they say? There's this one component, and maybe it's on this component here. It's just like a kind of like a guard in a bathroom, but what was exposed made it so they couldn't fly. It would have been $70,000 for the Air Force to get it created for all the planes that they needed, not to create one and to create a mold or a tool or a dot, but now they're 3D printing it and getting these planes back up in the air. So your tax dollars are hard at work and actually helping out to get this stuff out there quicker. They focused a bit at the beginning on the C5, now they're on the C35, but basically what they're doing is creating an iTunes library of parts that these Air Force bases can go and download. And everything's been processed, so they all know the exact material, the exact orientation, because University of Dayton Research Institute is printing, verifying, and then sharing. And so they're creating this library of parts that the Air Force can go and scoop out and use and print. More aerospace. Airbus, the new A350 has over 1,000 printed parts on the plane. That's on the plane. If you've flown on a Delta flight, you've flown with 3D printed parts within there's some in the cockpit, there's some in the bathroom, but people are starting to use this because, does anybody know why would you use 3D printing in aerospace? There are no bad answers. Sir, yes, you in the back.
Parts are stronger and easily manufactured and tailored to different specifications.
Absolutely. Customization. The fact that if they want if you've ever flown recently, you see the cool blue lights now. They can do customized stuff where they can see logos and stuff. So we'll start to see more customization. Lightweight. Flying is all about getting more people and more bags on it so those companies can make more money. If you can do something in plastic rather than steel or aluminum and you're saving time and money, awesome. And then at the same point in time, having backup spare parts to fix this. If you've done it in 3D printing, you have it in a library on a computer, not in a warehouse sitting on a shelf. So a lot of different areas. And they do 1,000 parts just in building up the plane. Think of how many they're doing as jigs and fixtures, customization tools to help the manufacturing process. So big area. Space, once it became commercial, and now we have all these companies shooting rockets in the air. If you've heard of Lockheed Martin or Boeing or Blue Origin, SpaceX, all these companies are now putting rockets into space, but rockets that actually can come back and land. ULA is another one of these groups. They use, all those companies that I named use 3D printing because of just like we talked about. Lightweight, customization, using plastic when they can, but also you see something, this basically duct. Traditionally, it's taking 140 parts. It's a stainless steel or aluminum. It's 140 parts that are being assembled. Okay? That's some significant assembly. Think of how many days it takes to do that, or how many hours for somebody in the manufacturing area, to 16 parts. When you can do something in 16 parts, you can send it to a machine that just builds overnight. You're saving time, you're saving money, you're saving materials, but then you're also saving those man hours. I am a fan of movies. I do have young kids, so these are kind of movies I see. But that missing link, has anybody ever heard of that? Those faces were all printed with Stratasys printers. Okay, so this group, Leica, I say Hollywood, they're actually in Oregon. But here is Kubo and the Two Strings. They did a movie called The Box Trolls. They did a movie called Paranorman. They also did a movie called Coraline. You can see each of those movies. Coraline's the first. You can see the transformation, the growth of this company and their technology over the years. If you've ever seen Coraline, Coraline maybe has 4 or 5 characters in it. And they did that because they would 3D print the faces, but it was before we had full color 3D printing. And so somebody would have to hand paint. And so there was a person hand painting each face. So they were using 2,000 to 3,000 faces in the movies. So not a ton of facial expressions, still very exciting. Not a ton of characters. Fast forward to Kubo, and they printed over 60,000 different facial expressions. There were way more characters in this movie, so their movies can get deeper. And yes, they look like child Gumby type movies, but they're very well written, very appropriate for adults, maybe less for children, but the children still like it anyway. My kids, they watch terrible stuff, so we're okay with that. But you see how they set it up. I always like to talk about this because the capability, the engineering, the ingenuity that goes into this is remarkable. Every face on the back has a printed number. So it's all coded. So they know exactly which frame they need, which face, because of which facial expression. Then they have magnets tied into it, and they've got their maquette that they're just basically popping on and off these faces. I believe it takes 3,000 frames to do 3 minutes of the movie. So the amount of frames that they're creating is ridiculous. I think now is a good time to pass around some models. These two that I'll pass out right now are polyjet technology. Our polyjet is, you saw the machine going back and forth. It's jetting a liquid. It's a liquid, and then we cure it with a UV light. So this UV light cures this. But there we can mix different materials. We could do rubber with rigid. We could do high detail. So this is printing at a micron level. So any of these mixed materials right now are printing at 28 microns. And we could go down to 14 microns if we just do a single material. Those are polyjet. I'll pass around some FDM, fused deposition modeling in a little bit. But look at the color, feel the texture, the rubber with the rigid, a lot of creativity. I consider this stuff like a chemistry set. You can see the realism that these are producing when it comes to look and touch and feel. Remember, this is a cartoon type movie, so they're actually meaning it to be that. Look at the heart, look at the teeth and gums that I'm passing around. This group actually won an award for the Moon Beast right there, because that was the first fully 3D printed creature, and they won, I believe, an Emmy for that. So it's kind of cool to see this group. They now have basically a production floor of 3D printers, and they actually lean on us when they'll alert us when they're in full production mode, because we'll have to keep one of our printers open for them if they need backup and more. So this most recent, The Missing Link, there must have been 20 some characters in this movie. They printed over 100,000 faces for this. So it's kind of cool. They're very, very hidden about it, but once it's close and they're starting to do some promotion of these new movies, we get to see some of those little parts floating around. So we knew about it a little bit before the public, not too much, because it's not like we don't have loose lips. Other areas that I'd like to show, and I've shown kind of the engineering aspect, a little of the medical, but then the getting into the arts and culture, because this is a big part of it. 3D printing isn't just for engineering students. It's not just for medical students or those arenas. There's a lot of art and design. There's a lot of culture. They're grabbing information. They're reverse engineering certain things and printing them so people can experience it. We talked about simulation training. Very similar in the world of anthropology, archaeology. To print a fossil, to print a bone, to pass it out. Obviously, it's not the original, but it's a lot more impactful if you touch it and feel it versus just seeing it under glass at a museum or on a picture. So you can really dive into it. Google, big user of our equipment. The only thing they will share that they are doing is recreating some cultural monuments and needs. I know they're working on cars. I know they're working on phones. They're working on so much top secret stuff with 3D printing, but these are the only things that they're actually sharing with us. I do want to talk a little bit about a recent release of ours, and it's digital anatomy printing. It is us taking this to the next level of printing a heart that feels like a heart, a bone that feels like a bone. It's taking it to that next step. The vision of our healthcare group is that in 5 years, there will not be a need for cadavers. It's a lofty vision. We'll see. But I like it. I like the idea of moving in that direction. But to be able to focus on vascular or tissue or bone, and then our vision is to develop 15, 20 more materials focused in these areas. And why? So people could practice. So we could do simulation and training, and every student can repeat it 15, 20 times. I coached T-ball for my 6-year-old, and I coached with the coach last year. And I remember one of the parents coming up and saying, "Really? Why we got to hit off the tee all the time? Why we? Well, one we're in T-ball. Yeah, but they got to get ready." And the coach I was with, he's like, "The best baseball players in the game hit off of a tee 1,000 times a day, even today. It's the practice, it's the repetition." So I always put it into terms of, okay, in this simulation, in this training world, the repetition is huge. But also, in these surgeries, whether it be oral or, operating on a foot, if it's something you haven't seen a lot, if it's something you see once a year, there is nothing negative about practicing, about printing it out, about seeing it, touching it, feeling it. At the same point in time, there's certain things that people may consider inoperable, but with a 3D model, it could potentially change their entire direction of that surgery. You don't need to know about this. This is kind of a cool thing. We've really simplified the software for this. So you don't have to be an expert on segmentation. You don't have to be an expert on basically printing and understanding the software. You have to be good, but we're trying to create it with a bunch of drop downs. You pick your anatomy type, you know what colors you have, and you can dictate how you go. We can even take bone and dictate whether it's a young person's bone versus an older person's bone because the densities are different. Very, very exciting thing. This is based off of what we call our voxel print software, where we actually allow people to write their own slicing tool to dictate voxel by voxel. Think of a pixel with a photo. A voxel is just a 3D pixel, and that's what our printers are dropping down. But it's based off that, so we're able to do some really creative stuff that we were not able to before. And here you can see the bone. I always like talking about the bone. Those 4 different densities up top is kind of how we like to showcase it, where just by using a slide rule, you can get to the design you choose to. And then we used to live in a world where our shore value, we could get to about 30. Now with these new materials, we can get to a shore value of 0. That's really exciting for those people that are actually doing, practicing these surgeries to get tissue to feel more like tissue. Now I want to show you a couple things that we're working on because we believe people see it as futuristic. These are automated printers. These are printers that will print, finish the part, cut the part, cut it, automate. Project time, backlog, printing, and get to a 3D printing. You have to manually and space in your printer, but that's still going to stop at some point unless you time it perfectly where it stops at 8:15 and you're able to be there at 8:15 and switch something out. You've got dead time. This takes care of the idea of dead time. So it's just stacks of printers with automation, ejection, printing on a film. I love it just because half the time what I like to do is help out different robotics teams or research groups or print parts for people that want to go show some stuff off. Now I can just load it. I can go to my computer, load it up, and our printer will start. And it'll print these parts. And then when I get to the office tomorrow, there'll be all these printed parts printed. So it's cloud-based, it's simple to use, and it's all about mass amounts of parts printed. And then this cloud infrastructure software, this is the interface. You drag and drop a part. It's really trying to simplify everything, because we get a lot of it from the colleges, the universities of, you know, we're getting people from all over the campus that are coming in, and they really don't have the understanding of how it works. They just want a part printed. They just want a vending machine to create. And then one of the other issues is Savannah College of Art and Design is a very good example of this. If you go into their lab, at majority of the time during the quarter, it's busier than a Starbucks. All these kids in and out, laser engraving, 3D printing, all this. And they have 2 people that work there. And so the act is you come in, you've got a jump drive or a thumb drive, and you wrap a note in it, and then you drop it in a basket, and then you walk away, because they don't have time to do that interaction, that consult, whatever. Then the next day, the day after, you keep coming in. Is my part done? Well, check the basket. Is my part done? Check the basket. Is my part done? Check the basket. It's, you know, it's as good as they've got going, and it works well for them. But now they have a website that the students can go to, and they can see their parts. They can see when their part is printed. They can see how long until their part is there, and then they can get notifications of your part's printed, it's done, it's over here. So really kind of bringing it all together and showcasing the ease of how we can make this happen for those universities that are printing a lot of parts. Final piece I want to hit on is, because of our customers, because of the request, Stratasys went out and created what we call an additive manufacturing certification. A lot of the secondary schools, the career centers, tech centers, the community colleges, technical colleges, but even the universities have requested that we create a certification. We have 30 years in the business. We own multiple technologies. We have patents on multiple technologies. But then we also own the largest service bureau in the country, probably in the world, what we call Stratasys Direct Manufacturing. So we know all the technologies. We have all of our competitors' technology. Now we're putting it into something that we can share with educators, knowledge transfer, and then allow you to offer a certification course on your own campuses. It's not for everybody, but it is for a lot of people. We've seen, we've got over 40 colleges, universities, secondary schools offering this now. We have over 300 students certified. And I say this, I think I get a request once every 2 weeks from a company, from another university. Hey, I'm looking to hire somebody. Do you have a pool? Well, we have a pool of people. I just got one on Friday. University of Colorado, Denver is building out a lab. They're looking to hire somebody. They reached out and they said, hey, who do you recommend? I said, here's a list of all these students that have passed the certification. Here's a list of all of these colleges and universities that offer the certification. Here's your first step of who to ask. They loved it. They loved it. They felt like it was such a powerful thing. On the other side of it, as a university, as a college, enrollment's declining. It's harder to recruit the students. The economy is good, so there's a lot of jobs out there. so we gotta, a lot of the universities, colleges are trying to build a strategy and drive people to enroll. You know, institutions see technology as an answer to this, but most are just applying it as patchwork. It's not a well thought out plan for a lot of people. A lot of people, it's, oh, they've got a makerspace, we got to have a makerspace. They have an innovation center, we need an innovation center. But there needs to be a strategy that provides that long-term impact. It is higher stakes. There are more opportunities. Like I said, the economy is good, so people are hiring. Students are going in for a year and getting hired by a company and not finishing their degree, their certification. So there's a lot of opportunities. So there are bigger stakes. So there has to be something. Why stay? It is an absolute statistical fact that there are fewer students enrolled, and that's between 2011 and 2017. And so there is more of a fight. Does anybody hear of FIRST Robotics? Good. It's good to see the younger groups. We need the older groups to understand, because this is where what I see is the most talented people are being created in that engineering design thinking. We at Stratasys have hired, I would think in the last 2 years, 10 to 20 students that actually have FIRST Robotics, FIRST Tech Challenge on their resumes, because these students are so much more well-rounded and understand how to work in groups and teams, but then how to communicate. This is huge. These students are being recruited as like athletes because they have the capability. And these are the students that are going to go and join your SAE challenge teams, your Formula Ones, your Bajas. But they're also those students that are picky about where they're going to school because they want access to what they've had access to, and they want more. The days are gone where only the juniors and seniors get access to the equipment, the 3D printers, the CNCs, that type of stuff. There's expectation that they get access as freshmen. We see universities building dorms with labs in them because the students are going at their choice hours. But this is all changing the makeup of what student expectations are, but also staff expectations. I heard it from Texas A&M. We're building this monstrosity of a building and this beautiful lab because we want to be able to recruit the best PhD students, the best researchers, the best professors. So it's a combination of why. So I highly recommend a strategy, and I believe our certification fits into that. Key components. This is our level 1 training. It does dive into the overview of additive manufacturing. It talks about the different technologies, the applications, the materials, the software, post-processing. So all these steps are what makes a well-rounded individual that really understands why 3D printing versus subtractive manufacturing. CNC is not going away, and it shouldn't. Metals is not going away. Woods isn't going away. But a really, really powerful tool is to understand when additive, when subtractive, when to combine both. We feel that this certification does it. Here's kind of just a glimpse of who's doing it. I was always blown away when these universities started requesting that they be a part of it, because I always thought of a certification as a community and technical college desire and demand, but it's not. The university, those students taking those 3D classes, those CAD classes, they're looking to have this badge, this certification. And we have over 20 companies that are backers or do support and have written us letters that say, hey, somebody with this is somebody we would look at if apples to apples on a resume, but one has the certification, that person has a leg up for us. So in closing, my motto is advance your technology strategy. You're going to advance your institution. With that, I would like to open it up to any questions that you may have. Yes, you, sir.
So on the polyjet part,
Yeah.
for that surgical institution with the blood vessel.
Yeah.
How did you guys do the, or how did they do the liquefied blood inside of there?
So they are monkeying with the software and absolutely jetting a liquid, but it is being cured. And then they're also doing a little injection into that. But yeah, I can put you in contact there.
That was really cool.
Yeah, they're phenomenal, and these types of trainers. So now I'm passing around a couple FDM parts. There are other groups that are doing similar, where they're doing like a brain surgery type or going into the brain, and what they'll do is they'll print the main part, and then they'll have that modular piece of printed, but they're absolutely injecting a liquid into it, because it doesn't sit for hours, it sits for 15, 20 minutes, and then they'll cut. If they do something wrong, oh geez. Good question. But think about it that way. They're making these training tools, but 3D printing isn't the 100% only way to do it, or you don't just print a part and it's always perfect. Sometimes you have to do a little post-processing to make it like you want. Yeah.
So just a little bit to me, so I'm trying to wrap my head around this. If you had a medical issue, how would they take, I noticed some of the parts of it, I think they were taken from CAT scans or whatever.
MR, CT.
And that just feeds right into the printer.
So there's another step, and Mr. Albers will go into it, but it's called segmentation. So you're taking a DICOM file, basically slices of something, but you're grabbing the proper densities that you want and creating the heart and eliminating the noise. So there is a little magic behind that. But yeah, it's something that is being trained at schools now. And as we move along that path where insurance is getting closer and closer to actually paying for 3D printed models for certain surgeries, it's becoming more and more important. Yeah, you want to add to that?
I was just going to say that as of 3 weeks ago, they are now reimbursable. However, insurance companies still working out a pricing structure on it. But
So that is massive, that now 3D printing parts for a surgery is reimbursable. The biggest adoption of 3D printing has been at the academic medical centers and at the children's hospitals. Academic medical centers, a university, they have cheaper labor. They always want to do research. If you've got a really, really tough case, you're typically going to those research hospitals. Children's hospitals, the donors there are ridiculous, because no kid should not be able to go through, get operated on, and stuff like that. But with CPT codes getting approved, we're going to see more and more hospitals do this. Not as a typical, hip replacement, but they may do certain jigs, fixtures, be like, yeah, I want to cut it rather than trim, check, trim, check, trim, check. You come out of surgery and you're all bruised up. Usually it's because they're banging. So to better to perfect that. Good question. Any other question? No? Good. Speed. Speed, we can go really fast. With the polyjet technology, if you're printing one part and say it takes 30 minutes, and in that same line, you're like, no, now I want to do 10, it'll take maybe 2 or 3 minutes more. Big blocky parts, that's going to take more time. On the polyjet side, which is the high detail, the full color, you can't honeycomb the interior and make it lighter. So you're always going to have a solid model. But it's fast if you're doing multiples. FDM, that is a layer at a time, and if you're doing 10 things, it's gonna take 10 times that amount of time, because you can't speed up that layer process. We have sped up the process 10 times, like 10x in the past, I would say 4 or 5 years, because we're fiddling with software, we're doing the material changes faster. If you've ever used Dimension versus an F-Series, it's about 50% faster. And we're speeding up the process to remove supports. So we've got a formula that's even faster. Yeah.
I was going to say, for reference, we use PolyJet at our hospital. To print a skull of a 16-year-old is about 24 hours. To print 2 of them, it's about 25 hours. Right. Just to kind of go into when you add it in parts, realize not that much time.
Right. Yeah, exactly. And as you think about it, we call it rapid prototyping. It's not instant prototyping. And think of what it took you to create something back in the day. Like I said, I've got 2 young kids, and if it's not instant, it's frustrating. And I try and kick them and tell them, you know, you got to be patient. That you're doing something that's never been done before. I don't see you whittling it out of wood. So, but the speed is getting improved. The materials are improving daily. We just released a material it's a PEC with electrostatic dissipative properties, because the aerospace market wants it. They want to be shooting these putting them on satellites and shooting them into space. So a lot of benefits. So younger people in the crowd, learn CAD, get to know CAD, run with it. That's a language that is way more beneficial than Excel spreadsheets and PowerPoint. So jump on it. Excellent. Well, I appreciate your time. I'll stick around. I'll be available for questions if you're shy, and if you need anything else, we'll be here for you. So thank you.